we are going to present our tool for DSL, for context-aware mobile application. This is a part of our team of Universidad Nacional of La Plata from Argentina and Universidad Army Forces ESPE from Ecuador. Our agenda is background, related context-aware mobile applications, a taxonomy of factors that should be considered for context-aware mobile application for design and building approaches, construction of DSL with the video designer, serious video designer, discussion and conclusion of future works. It's natural to ask that how can context-aware systems be useful? And well, before we answer that question, we have to define what's context. We would like to define by breaking it down in 4 parts: who, what, where, and when. Who? This is your identity and relates your gender, age, weight, height, background, profession. What? This looks what your current activity, ambience, and interests. Where? This is your location, but also what type of taxonomy can we attach to location? Example, home, office, commercial, residential, restaurant, etc., and more attributes of location. When this tells you what time of the day, week, month, year, etc., is relevant for the current context. Technological advances have determined that a wide variety of range of mobile applications with IoT sense of data, with artificial intelligence, home automation, but it also has been addressed by different authors in different perspectives. Some of these perspectives are specifically oriented, for example, offering solutions, while others are building approaches of this kind of application. That is, context-aware mobile applications are being studied at different levels of abstractions. But today, there's no unified solution. There's still no consensus on how to classify the context or which characteristics should be considered relevant in the development. Therefore, there's currently no unified solution to such kind of application. This is an aspect of research and open research. There are currently a number of approaches with working with the WLAN, beacons, and so on. So there's indoor location system with variety of location sensing mechanisms. Developing context-aware is a complex task. Building approaches speed up this task, and they consider 2 different options. For non-spare, for example, App Inventor allows configuring and creates application for outdoor spaces. Here we have a view of perspective of this type of application. Create application only for outdoor spaces. It's not possible to combine accelerometer with sensor with orientation sensor. Focus only in context for device of user location. So, development of approaches for expert people is web ratio. Web ratio is only for expert users and working only for GPS and location sensing, precision and accuracy configuration, and creates only application for outdoor. Defining context related to device, network, connectivity, and position. So these 2 points of view, derivative applications are limited, address certain specific aspects on GPS, and have restrictions related to available APIs. In order to solve this kind of problem, we have defined, proposed in different papers that we have write and present in some Congress, how to manage this building approach. And the answer is taxonomy of factors with different characteristics. Relevance of each defined context, allowing to generate reduced versions of applications with the most relevant context. For now, approaches do not indicate relevance explicitly, but everything defined is relevant. Combination, identifying which contexts are combined, how contexts behave, and when they are considered together. For example, some indoor location sensing mechanisms could be combined in order to more precisely work. Precision and accuracy for each sensor, example, GPS. Each indoor sensing mechanism have its own configuration. Passive configuration, which the user performs manually. Active configuration, application itself, based on behavior, is required monitoring and learning mechanism. Categorization is the approach should have the way to categorize context, user, objects, environment, considering how each category is derived inside applications. Type of execution requires passive and active execution. Passive requires the intervention of the user, for example, QR codes. Active execution, automatic sensing mechanism, for example, GPS. In this context, we have decided we have evaluated several tools in order to construction of DSL. The most important and the most possibility that we have is for domain specific language is Sirius and we have what is the purpose of this? The purpose of this is the domain specific language, which are created for supporting a particular task and typically programming for language, and they are like hammers. If you can use a hammer to open a barrel, but it's better if you use a specific tool like an upper cane. Okay, so this is very important to give the users the appropriate tool for creating this. In this context, we have the considerations for our DSL. First of all, we have a meta model in the core. We have a Sirius base with OVO already designed. So we are going to focus in this type of tool. And afterwards, we are going to use Xtext and Accelerometer in order to, by using model to model, model to text, create an application of Android. Okay. Here we have a view of our meta model. It includes where object, context feature, relevance value, and all of the considerations of our taxonomy. Okay? This is important to remark that we have to define explicitly in this model, and we have to be very accurate to express what we need. For example, rules that not only control but also give observes and update context features. Also, we have here a brief screen capture of the launch of the runtime in order to create. We have for sure intermediate models that we have to create, and we have launch and create the new representation in viewpoint. This is the definition of case. Case one, we have object mobile. For example, we have in case one, we have an automobile that is located where in outdoor spaces. So we can check for outdoor spaces of indoor space. Also, we can combine different aspects of context-aware by category value. And very important to see that it is not only for outdoor position. For example, here we can address the problematic of outdoor with the monitoring of the weather, and we have abstract sensor and concrete sensor for monitoring the weather. Also, we have over here an indoor positioning case. An indoor positioning case which could be implemented by using different abstract sensors like beacons. And we can define the implementation. We can apply a rule, for example, analyzing the control of the position inside. We can manage, we can configure a service for indoor position. And here we have a testing, a final test of our tool. This is a view of the cases generated, and we're going to take a look over the tool. Okay, here you have the tool and different kinds of elements in MetaModel. Afterwards, we have a runtime, and in a runtime, we have used these tools in order to create the different study cases. The taxonomy of factors are developing depending on how we'll use experts or non-experts. By user experts, there are factors of relevance that should be considered: precision, accuracy, between others. Understood by non-expert users, it's important to have categorization of context on how it's presented from the approach. GPS allowing approaches, generate applications for outdoor applications, and flexibility provided by building approaches. Taxonomy of approaches proposed could combine to improving the flexibility of approaches. Conclusions and future work. Our DSL is already constructed and we have tested for indoor and outdoor context-aware mobile applications. We will be designing the process with Axileo Xtext for generating Android context-aware mobile application. And we will be generating a mobile application text. Also, we will explore how to enrich taxonomy with, for example, aspects for context-aware aware mobile applications and different topics in addition. Contacts you have over here. As you know, we have a research team, and this is a part of our team. Okay, this would be for now, and if you have any questions, I'm ready to answer them.
Okay, thanks. Thanks for this presentation. And yes, we have a question for you. And a congratulations for your work. Very interesting. Just one question. In what field of action do you think your proposal will have a greater applicability in the future?
Well, one of the applications that we have, for example, is in tourism. Smart tourism is one of the different topics that is increasing nowadays with Internet of Things and with sensors. So the location and the context aware is now for smart tourism is one of the and also for smart parking and smart cities is context aware is very application for this type of problems.
Okay, thanks for that. Well, maybe one question from my side. Have you experienced this approach in an industrial context? And is there any feedback about, let's say, more operational usage?
Well, we have been researching this type for approximately 2 years, and we have evaluated some different tools, and finally we have found it serious view that we consider that includes all the characteristics that we need for designing and developing this type of applications.